If the Tiger tank was the king of the World War II battlefield, then in front of this monster, it wasn't even a toy. It weighed 1,350 tons, and a single shell weighed 7 tons. Today, using 3D animation, we will break down the craziest land battleship in human history, the German railway gun. Why were the Germans so obsessed with building these monsters that could only run on tracks? Simply put, they were deeply infatuated with the thrill of, you can't see me, but I can blow you into dust with one shot. As early as World War I, their famous Paris gun sent shells into the high atmosphere at over 40,000 meters, leaving the enemies more than 100 kilometers away, completely oblivious to where the firing came from, while explosions burst over their heads. The Germans completely tasted the sweetness of safely bullying their enemies from an absolute safe zone. By World War II, facing the supposedly impenetrable Maginot Line, the Germans' firepower obsession went completely out of control. Since field guns couldn't pierce it, they decided to bring battleship main guns onto the land. They literally ripped the main guns off battleships, welded them onto train chassis, and created the ultimate land avatars. However, cramming a battleship main gun onto a train immediately triggered a hilarious physical bug: spatial interference. Take the K-12 railway gun with its 33-meter ultra-long barrel. To fire the shells further, the muzzle had to be raised high. But the recoil of this thing was so terrifying that once it fired, the huge breech would violently slam backward and downward, instantly smashing its own chassis and tracks to pieces. How to fix this? German engineers came up with a brutal and simple solution: hydraulic lifting chassis. Before firing, the giant hydraulic cylinders on the chassis would engage simultaneously, lifting the entire hundreds of tons gun mount more than a meter into the air like a weightlifter, clearing out the recoil space for the breech. Even crazier was the microscopic battle inside the barrel. As everyone knows, for a shell to fly stably, it must spin at high speed before leaving the muzzle. How does it spin? It relies on the rifling. Simply put, the inner wall of the cannon is not a smooth iron tube, but carved with spiral grooves. The entire 33-meter-long giant barrel is essentially an oversized nut. How does a regular shell spin inside? At the moment of firing, thousands of atmospheres of pressure force the soft copper driving band into the hard spiral rifling, making the shell spin out of the muzzle like a tightening screw. But once the chamber pressure is too high, the driving band will instantly melt and strip away. The shell loses its grip like a runaway horse and just flies wildly after being fired. Since soft copper couldn't handle it, the Germans went for the ultimate craftsmanship alignment, developing a pre-rifled shell. First, since the barrel was a ready-made giant nut, they simply cut multiple protruding steel teeth onto the shell itself, turning it into a giant screw. When pushed into the chamber, the steel teeth slid directly into the existing rifling grooves, spinning smoothly out of the muzzle. This was the true foundation for ultra-long-range strikes. The most fatal weakness of the railway gun was the tracks. Once the tracks were bombed by Allied aircraft, these giants would become stationary scrap metal waiting to die. To give the giant gun legs, German engineers even proposed the craziest hybrid brainstorm in WWI history. First, disassemble the entire railway gun into pieces. Next, remove the turrets of 2 Tiger tanks and use them as mobile chassis. For a 33-meter-long barrel like this, it would no longer rely on tracks. Instead, like a giant steel centipede, it would ride on 2 Tiger tanks and crawl through the wilderness. Only when it reached the designated position would these parts be reassembled back into that earth-shattering god of destruction. But this idea was too wild and remained entirely theoretical. Besides the leg issue, there was an even more embarrassing bug. The railway gun had no turret. It was like a sniper with his neck in a cast. Because it could only move forward and backward along the tracks, its firing angle was locked tightly to the extension line of the rails, making flexible shooting impossible. To give the giant gun a neck, the genius Vogler turntable came into being. The brilliance of this system lay in its perfect replica of the compass principle. Driven by power, The entire train would use the locomotive's pivot as the center, dragging its long body to slide slowly along a circular track. Just like that, this steel straight man that could only shoot in a straight line instantly transformed into a mobile fortress capable of 360-degree all-angle firing. No matter which direction the enemy was, they couldn't escape being locked on. If regular railway guns were cannons running on tracks, the 1,350-ton Gustav was practically moving an entire steel mill to the battlefield. The silhouette of this monster was enough to block out the sun. It stood 12 meters high and 47 meters long. But just that giant 800mm caliber barrel weighed over 400 tons. Because its body was too massive, it couldn't travel as a whole unit like regular trains. It had to be split into over 20 giant modules to be transported to the front line for assembly. Since no existing railway could bear its weight, German engineers had to lay 2 completely parallel railways from scratch in the wilderness. Note, not 2 rails, but 2 entire railways, 4 steel rails running side by side. Then, the left chassis of the artillery would roll in along one track, and the right chassis along the other, like 2 hulls of a catamaran slowly closing together on the position. Finally, several specialized giant Krupp cranes would work simultaneously, lifting the barrel into the air and dropping it precisely onto the gun carriage between the 2 chassis. The entire assembly process took nearly a month. In other words, just inviting this deity onto the altar was already a massive civil engineering project, and what Gustav pursued was pure quality dimension reduction strike. The high explosive shell it fired weighed 4.8 tons, equivalent to throwing an adult African elephant 48 kilometers away. The armor-piercing shell was even heavier, weighing 7.1 tons, equal to the weight of a light tank. The moment it blasted out from the muzzle, its initial velocity reached 720 meters per second, more than twice the speed of sound, enough to smash through any fortified bunker in the world at the time. But behind this earth-shattering power lay a desperate logistical nightmare. To make it fire, not only did construction have to start months in advance to lay 4 rails, but it also required over 2,500 laborers and engineers. Just the loaders responsible for pushing the shells and cleaning the barrel numbered 500. The outer perimeter was packed with anti-aircraft artillerymen and military police. Serving this deity required a staggering 3 heavy locomotives and 71 train cars, forming an endless steel dragon of ammunition cars, generators, barracks cars, and mobile kitchens. Behind this extremely bloated organization was an absurd economic calculation. The cost of this beast was as high as 7 million Reichsmarks, enough to buy 25 fully equipped Tiger tanks. The extreme cost made ammunition an untouchable luxury. Throughout 1941 to 1942, the German military factories only produced a few dozen 800mm caliber shells. The inability to mass produce ammunition proved that this was not a practical weapon at all, but a gold-devouring black hole, purely meant to satisfy the High Command's giant object worship. To cover up the awkward practical inefficiency of the railway gun, German engineers even made ridiculous technical struggles. They developed the Peenemünde arrow shell, which had a range of up to 150 kilometers, but weighed only 136 kilograms. This was equivalent to putting a toothpick into a shotgun, wrapping a plastic casing around it to keep it tight. After going through immense trouble to shoot this toothpick 150 kilometers away, it turned out its high explosive payload was a pathetic 25 kilograms. This was equivalent to spending enormous effort just to drop a large firecracker on the enemy's head. And what truly killed these steel giants was their absolute reliance on railways. Later in the war, the Allies seized air superiority. Allied bombers didn't need to head-on clash with hundreds of tons of thick armor. They only needed to bomb and break the railway bridges or switches in front or behind them. Once the tracks were broken, these land battleships that required 4 rails to serve them instantly became trapped targets that couldn't even move. Most railway guns weren't even destroyed in artillery duels. They were captured directly by the Allies like scrap metal in railway crane yards. At that time, a young engineer named Werner von Braun realized that artillery caliber and physical limits had reached their end. Instead of stubborn confrontation on railways, it was better to turn their eyes to the sky. Thus, the famous V-2 ballistic missile was born. This was a pure dimensional reduction strike. Firing a railway gun required laying 4 tracks and thousands of people serving for months, only to fire shells costing as much as a supercar. Meanwhile, the V-2 missile only needed a mobile launcher vehicle to drive into a forest clearing, erect the rocket, and ignite it into the sky. A few minutes later, it could carry a warhead weighing about 1 ton to strike a neighborhood 270 kilometers away. The range was 5 times that of the Gustav, and operational efficiency increased exponentially. It no longer required laying a single inch of track. In front of the V-2 missile, those giant guns grunting and laying tracks in the mud instantly turned into a pile of useless scrap that was all show and no go. It was precisely the ultimate clumsiness and inefficiency of the Gustav that completely buried giant gun doctrinism, yet inadvertently pushed open the true door to the missile era for humanity.